All right, so we're going to get started. R1. So this is the first lesson. So this just means review one, and we're basically going to just review Pythagorean theorem. All right, so Pythagorean theorem relates to what? What are we talking about?
Triangles.
Let's give me an answer. Who had an answer? Right triangles. Particularly what on a right triangle?
The side.
The sides. So the sides that are next to the 90 degrees adjacent, these two sides here are called the what?
Legs.
Legs. So we usually use A and B for the legs, and then the longest side is called the what? Hypotenuse, and we call that C. So C is the hypotenuse. It's the longest side. Okay. All right. So what's the relationship between the sides of a right triangle? What's the Pythagorean theorem say?
A squared plus B squared equals C
A
squared.
squared plus B squared equals to C squared. So if you know, if it is truly a right triangle, then those have to be the side lengths. And so the two legs, if you square them and add them up, it has to equal to the square of the hypotenuse. So an easy one, let's try this one. Let's see if this is true. Is a 6, 8, 10 a right triangle? So if the two sides, so let's just check. So does this represent a right triangle? So plug that into the Pythagorean theorem and see if it's true. When you plug it in, it should add up to whatever 10 squared is. So this way we can double check it. So if we do Pythagorean theorem, we have 6 squared plus 8 squared equals 10 squared. All right? And 6 squared is what? 8 squared is what? 64. 10 squared is what?
100.
Is 36 plus, does 36 and 64 equal 100? Yeah, that's it. Now typically you're going to find a missing side, okay? So typically you'll have to find a missing side. So now, let's say, here we go. So we'll call this example 1. Given the legs of a right triangle are A equals 5 and B equals 12. Find the hypotenuse C. All right, so now take a second, go through, see if you can plug those into the Pythagorean theorem, and how would you solve for C, and then we'll all do it together in just a second. Give you a hint, you should get a whole number for your answer. There should be no square root. So I call this type of a problem is like a plug and crank. You know the formula, you just got to plug it in and crank out the answer. We got to make sure we do the steps correctly. So what am I going to write to start with, Hank, right? What do we tell me what to write?
5 squared plus 12 squared.
Equals
C squared.
C squared. So notice we want to find C, not C squared. So we're going to have to use our square roots a little bit. So if you did 5 squared, what do you get?
25.
25. You do 12 squared, what do you get?
144.
144. And you add those two up, what does that equal? So I tell you right now, some people will put the answer 169, but that can't make sense because you can't go 5 and 12 and then the hypotenuse is 169. I think that's a lot. So now our last step is to solve for C, is we need to do what to both sides? Square root. So I'll take the square root of the left and the square root of the right. Now you have access to your calculator. TI-84 or 83 is the recommended calculator. Or you just can memorize the square root of 169 is what? 13. There you go. Okay? All right. May not always be pretty like that. Maybe we do the work and maybe you get a square root, it's okay. So let's just say, we'll do one more example. I'll change the sideline. Say A is 1, B is 3, and you're gonna see that you won't get a clean answer. Just do this one real quick. See what your final answer is, and just leave it. If you have a square root that you can't get a whole number for, just leave it as a square root. Don't go and try to work it out. So try this one. A is 1, B is 3, find C. So try that one real quick. Okay. All right. Got an answer? Leah, what did you get?
3.16,
Leave it as a square root.
square root of 10.
Square root of 10. So it'll tell you, we'll see when we do, it may say either put a decimal to 2 places or leave it as a square root. So when we get into my math lab, we'll see how they want us to write it. But if you write this out, 1 squared plus 3 squared is C squared. 1 and 9 is C squared. We get 10 is C squared. So square root of 10 is C squared, oh, I'm sorry, is C. So maybe we put the answer with a square root. This way it leaves it exact. If you did use a calculator and it would give us 2 decimals, so if you round it to 2, what did you get?
It was 3.16.
What's the third decimal?
2.
All right, so 3.16 is correct. Okay, so either of these, we'll have to see when we go into my math lab how the computer wants it. It'll say leave answer exact, you leave it like this. Round it to 2 decimals, you put it like that. So leave exact, you leave it like that. Round, I just put 2 decimals, I don't know. We'll see what it asks. That's that one. Okay. All right, that's if you're given both legs. The other scenario is maybe I'm given what? What might be different? Leg and a hypotenuse. These are really the only 2 scenarios. So now we'll do, I'll erase this one. So the good thing is say, oh, well, I want to see this again. It's going to be on the video that I'm going to send. Okay, this is getting taped right now. Okay, they can't see it. Can I erase? Good? All right. So we'll go to example 2. Now I'll give all right, so example 2, given side A is, let's just say side A is 3 and C is 5, the hypotenuse. Find the leg B of the right triangle. Okay, so go ahead and do that one, and then we'll do another one like this. We'll call this part A, and part B we'll say side B is 7, and side C is 11. Okay, and we'll do that one. And this one we'll do, this one we'll leave exact. So we'll do these 2 examples, and that should be a pretty good review of Pythagorean theorem. Let's check the answer to the first one. I'll give you a hint. It's the number of sides for a square. All right, that should be the answer. If you said 7, we got 2 issues. Okay, you messed this up, you don't know what a square is. So let's look at it. So we plug in. 3 squared plus b squared is 5 squared. All right. So I plug it in. What should be the next step? Yeah, I would square the numbers. That's right. That's how I would do it. I think if you go to my math lab and look for help, they may solve for this first and then square and then do the square. But I agree with you. I would square the numbers. So 9 and b squared is equals. I'll put an extra plus there. Then it's not. Haven't taught in a while. All right. There's that. So always in math, when you want to solve for something, we're trying to find b. The idea is to get it where? Get b where? By itself. So to get b by itself, you would do what? So if we're adding 9, the inverse of adding is subtraction. And we subtract 9, you got b squared is 16. And then last step, take square root of both sides. And if it is a perfect square, great. If it's not, maybe we got to leave it as a square root. You know, if we had square root of 15, we would leave it. There you go. There's the answer. So I picked the next one is one that should not be clean. It probably is going to be a little nasty looking, but we said leave it exact. We'll see what the calculator has us do. So on this one, we said a squared plus 7 squared is 11 squared. Then I agree with what Allison said. She said, go ahead and square 7 squared is 11 squared, 121. All right. And then we'll subtract the 49. So what is 121 minus 49? 72. Very good. So a squared is 72. So you can leave it square root of 72, but square root of 72 can be simplified. So you may not be familiar with this, but I want to show you. Now, if we were decimal, you would just type in on your calculator, square root of 72, get a decimal. It's got to be 8 point something. What's the decimal for this if we wanted it? 8.49. So it's approximately 8.49. This can be reduced. So if I wanted to reduce the square root, I just wanted to show you this real quick, just in case it's expected. So the question I would say is, can you multiply any numbers that are perfect squares that give you 72? Can you do a multiplication? So 2 numbers that multiply to equal 72, is one of them a perfect square? What's that? You can do 9 and 8, and 9 is a perfect square. You can go bigger than that. What's 2 times what is 72? 2 times rusty. 2 times 36. So the other thing I want to show you is you could make, you could make 72, loosen, sorry, forgot, I gotta remember this is the window here, over here, sorry. So we've got square root of 72, we can make it 36 times 2, and by writing it like this 36 comes out as a 6. So you look for which is the perfect square, and you can say, well, I can do the square root of 36, and it becomes 6 square root of 2. So that's the other way to reduce the square root. I don't think you're going to have anything like that. I think you just put it as a decimal. But if we get, you'll work on this today, and by Wednesday we can take some questions and see what the issues are. Okay? Does that serve as a pretty good reminder of Pythagorean theorem? Okay? So what do you have to kind of refresh yourself on? What do you have to remember? What's the point of this? What are we studying? What concept? Algebra. Are we solving for a variable? All right. Are we doing squaring? Are we doing square roots? Yeah. So there you go. Solving for variables, squaring, square roots. It's just kind of a review of that. Okay. That's it. First lesson, Math 1710K, college algebra. We're done. Good, yes, give it a hand, wrap it up. Well done.
16 minutes and